Hello, my name is Shimon and I worked on the AI behaviors in the game. So, the enemies in the game have several states. Um, they will wait for when the player appears in the line of sight, and they will move towards a closest empty tile around the player, and when they get in range, they will attack them. Their line of sight um, is blockable by the environment. So if we move to a couple of enemies down here, you can see that they cannot see me because I'm behind this wall. I have also developed the bosses for the game. So I will enter no clip mode to move to the boss area. And when I step through this door, the boss fight initiates. This boss spawns um, little crab enemies every couple turns and has an area of effect attack. So let's kill this boss and move to the second scene. I'm gonna use a debug command to move to the second scene. So there were other enemy types in the game which reuse the same behavior but have different stats. So I accidentally died here and had to reload the game to bring me back to this position. Um, I also created a second boss which also reuses the behavior of the first boss, just with different stats and uh, different enemies. So let's now take a look at how these features were developed. So I created a range of behavior selection components. First, we have the behavior component, which defines a single action that the AI agent can do. So the act method is the method that defines what the behavior will do. For example, at the beginning of an enemy's turn. The behavior classes are driven by events. So when the behavior receives what's called a behavior event, it can find a change in the behavior. The behavior event passes in a target behavior and an event to read. This then needs to be mapped in the function map, which basically casts a specific read event type to a specific function. The developer can then read the casted event and extract data from it. The event response function automatically checks the function map, and upon receiving a behavior event, it will check the function map if it contains the event and execute the function that is bound to it. Next up is the state machine class, which acts as a storage for behaviors and allows for transitioning between them. So what the methods of the state machine do is they will look at the current state, which is a behavior, and act the function on them. The event response will send it to the current state as well. And it also has an on transition received method, which happens when the state machine receives a state transition event, which will call change state to new behavior contained within the transition. Now, this change state function actually forgets about the old state and starts the new one from scratch. And next up, we have the planned behaviors, which use the GOAP pattern. They use this type definition of a fit action, which gives each behavior in the GOAP planner a fitness value. When the planned behavior is initialized, it will generate a behavior list, which is a list of all the available actions that the agent can perform, which are behavior objects. Uh, then the planner will generate effects. These effects put influence on the fitness values of said actions, and they use names as keys in the hash map to speed up search times when finding what influence to affect. The act function follows this sequence of world analysis. The world analysis method finds out which effects are active and which are not. It then follows on to action analysis. The action analysis will apply the influences from the effects to the actions. The fittest action is chosen out of all the available, which is the one with the highest fitness value, which will then be the behavior that is chosen during the act method. So let's now see how these systems were used within the game. So enemy behavior uses a enemy state machine, which starts off with the idle behavior as the base. The idle behavior inherits from the behavior class, and during act it will pull the pathfinding machine to check for line of sight with the player, and if it does have line of sight, it will invoke the transition to a combat behavior. Combat behavior is a planned behavior, and it gives the enemy actions to attack or move towards. It has effects for being in range and out of range of the attack. During world analysis, it will check um, uh, on the method of the attack action whether the attack is in range, and it will trigger the needed effects. And during action analysis, it will find the most fit action, and if the fittest action is moved towards, it will set the target to the closest empty tile next to the player. The attack action is a derivative of the behavior class, and it has custom methods for finding whether the attack will hit, or like finding which direction the attack should be performed. Enemy behaviors are not event driven, however, player movement behavior is. So a function map was created for the movement behavior, which maps events such as the key down button onto functions which generate a change in the behavior. I also developed the pathfinding machine class for the engine. This is a singleton which allows the developer to generate some data about the environment. Find path finds a path between tile A and B using A star, using Manhattan's distance as the heuristic. Line of sight will generate a line between 2 points and inspect its segments to find whether the tiles that it intersected were a wall. Line intersection uses the same algorithm, but outputs all the tiles that the line intersects, and find closest empty tile function uses breadth first search to find an empty tile around a goal position that is closest to the start position. These functions output a pathfinding data object, which basically stores all the information that was found during the search and allows the developer to reuse that information to perform further searches. And this concludes my contribution to the engine. Thank you.